Those guys coming in, ready to go?
Yeah.
Hmm? Okay. Do I need to stay behind the podium, or can I walk around?
I've got the frame.
Okay.
I think the mic's up there too. I think you get too far in the mic.
Ah, right on. Yeah, I tend to wander.
It's hard to stand still when you're giving a talk.
But I like in like real world meetups to get a little closer. Okay. All right. So I have been coming to these meetups, real world meetups, since before COVID, so 7, 8 years, something like that. And I kind of really like these because you get a different kind of conversation than what tends to happen online. So preparing for this thing, unlike Chris, preparing like a really nice presentation, I just came up with shit I want to talk about because I couldn't find an overarching theme. But as it happens, it came together. There's really about 4 things that I want to talk about in here. 2 of which are more near-term tactical, and 2 are a little bit longer-term strategic. So it's shit Sliptonic wants to talk about. I'm Sliptonic, real name Brad Collette. I kind of work on the CAM workbench. I'm also on the FPA and have been around the FreeCAD project for a long time. So the first kind of tactical item here is looking into regressions. And I did a little data analysis on it because I was seeing that like every Monday we do our merge meeting, and part of that we specifically look at the regressions that have happened. And I'm seeing that like regressions getting a lot of attention, but also the total number of regressions out there is kind of steadily increasing. And I wanted to know, am I making that up or is that really happening? So I dug into this, and there's sort of, since the tracker has been in place, there's almost 1,000 regressions or labeled regression issues. And they are growing. Now, that's not necessarily a bad thing because we're looking for them now. Like we've got a label, we're giving them a lot of attention, and so they tend to get a lot more focus. But roughly, the regressions as a percentage of the total issues is increasing. And you can kind of see the numbers there. 2026 is incomplete because that just goes through where we're at right now. But you can see that the percentages, from 2022 to 2025 went from about 1.6% of reported issues up to close to 10%, and we're on a run rate to be over 13%. So digging into, well, what were they? There's some, we can dig down a little bit farther and start qualifying them. And the vast majority of those kind of concentrate in the geometric modeling core, not just the core of the application, but this is really Sketcher, part design, and the core application. And the reason for that, sort of contrasting that with the leaf workbenches, CAM, FEM, is that anything I do in CAM can only break CAM. But things that touch into Sketcher and part design can break all over the place. And those things are, and that's exactly what we see, is that the changes in that core stuff end up causing the regressions that pop up. Those numbers are not driven just by the number of pull requests in that area. Like CAM gets way more pull requests than Sketcher does, but Sketcher's touches everything important and so tends to hit that. There's also like a big correlation of which workbenches are primarily Python versus those that have a lot of C++ code, where the risk of crashes is higher. So the one outlier in this is the assembly workbench. And probably the reason for that is that assembly both has a lot of C++ in it, so it's crash prone, but also it's young, and it's been undergoing a lot of change. It has the assembly work started when ONSL was up and running, but it was always intended to become a core part of FreeCAD and maintained by the community. Since ONSL shut down, most of the work on assembly has been done by paddle stroke, Pierre. And so what is kind of happening is like a lot of stuff going through one guy who's also working Sketcher and so forth. So possibly he needs help in this area. But more importantly, the assembly workbench really needs to have, or would benefit from having, not like necessarily deeper code review, but more people involved in steering the conceptual direction and making sure that we're building reliable code and also code that can extend for additional features as it goes along. So then go beyond where those regressions happen in the code base and start looking at what the PRs are that are triggering them, the culprit PRs. And you know, like I said, the spoiler is it's not about the size. It turns out that the PRs that ended up causing regressions actually got about 3 times as much review time as the smaller typical merge, or the typical PR that got merged. So merge time, typical one is about 3 days. The ones that caused regressions was about 9 days. So the difference is not how much scrutiny it's getting, it's the complexity of the underlying PR. And it comes right down to the size, number of lines touched, or number of lines of code, and the number of files touched that are in there. So mitigating or managing the size of PRs is probably the best thing we could do. Coming out of that, there's a couple of recommendations. I think we're kind of steering towards an area where we maybe have 2 high-level merge policies, where we identify the PRs that are likely to trigger regressions and make sure that we spend more and more of our scrutiny on that, and take a lighter approach to the leaf workbenches that are less likely to trigger these things, and where more of the user-facing functionality and features is showing up. That would probably satisfy a lot of people, that we move quickly and introduce new features and still allow us to put our maintainer effort and our review effort on the ones that are likely to cause more cause regressions. Another thing is adding some kind of a tripwire, something where we could algorithmically detect PRs that are of a certain size, touch a certain number of files, automatically be flagged for specific review. Again, I'm looking at, what I'm seeing is watching the merge meetings on Mondays, partly because of the AI, but also because the project is just getting more developers and is getting more attention. The number of pull requests that are coming in is steadily climbing. I've been generating a chart on this for the last few months, and it isn't slowing down at all. But you go to the merge meetings and you look at the queue of what's outstanding, and you're seeing the maintainers really getting burned out. It can be a little demoralizing that you meet and review and review and review and merge and merge and merge and go back in, and the queue is bigger than it was before. And overall, I'm suggesting that we probably need to look for ways to lighten the burden on maintainers without sacrificing the quality of the work. Investing in bisection. We do pay somebody as a bisect specialist, and this really works. The ones that do get answered get answered faster or get resolved quicker. So I think that when I say invest in bisection, it's not necessarily paying for more bisect specialists to do the work, but it's also making sure that we document process for how to do a bisect. We help people set up so that they can do a bisect quicker, and they know how to do that, and then can report that into the issue. So let's see. Then there is something else that sort of happens I call the stale tail, and this is the regressions that got reported and then got some attention, and then they're still out there. And breaking that down, there's about half of that. Right now, at the time I ran the data, there was 120 of those, 120 issues that are open and marked for regression. And about half of that are less than the median age. So call those like healthy. They're going through the process, right? They're getting reviews, there's a back and forth dialogue with whoever originated the issue. There's some investigation going on. Maybe there's a pull request. But if it's under the median time, I'm suggesting that it's at least on course to be resolved normally. That's about half of them. Then there is the ones that are called genuinely hard. And these are interesting because of the 30 that fall into that category, 21 of them have a very unique pattern where somebody worked on it, submitted a pull request, somebody reviewed the work, and said, didn't fix the problem, or fixed it but not completely. And then it stops, and nothing else happens after that point. And it's almost like whoever was working on it took their shot, tried it, said, I'm out of ideas. And then nobody else steps in, I'm speculating, but maybe because they look at the PR and go, well, somebody's working on it. And so it never gets picked up again. And then it just kind of goes stale. There's also those that stall for another reason. There's about 25 more where maybe there's somebody assigned to it, but if you look at the comment history on it, there's pings. Is this still an issue? Is this still an issue? And never getting a reply back. And they just sort of end. And then there's kind of the quietly dead, which I think is mostly a matter of just pruning. So yeah, if we take the ones that are in this stale tail, it's not one bucket of things, it's really three. So to propose some possible resolutions to this, I think that those genuinely hard ones, the ones that have got some attention and then sort of went quiet, would be an ideal place for us to start putting bounties and add those, just identifying those to go into the program that Chris talked about that are, have bounties attached to them and can get more attention. That may be one way of spurring additional development. The stalled ownership one, I think if a good piece of work would be for us to create, like right now we have several GitHub projects. What we don't have is a GitHub project that collects everything, every PR and every issue in one place. We have a merge queue, and we have the Max bot who triages all the issues that comes into the tracker. Does a fantastic job with this, but they're added to the merge queue. And this really is it's a GitHub project that's used during the merge meetings for us to know what to focus on. And it's really Max kind of keeping track of that. I'm suggesting that we could have a single project with an automatic trigger that every PR and every issue automatically gets added to it, and then we create individual views for the merge meeting, for the regressions, and to that we could add a tracker view that identifies the stalled issues that are, where they have just stopped moving forward, and the quietly dead ones can then get pruned out. So that is issue number one that I wanted to talk about, just general handling of regressions and then what we can do to tweak our processes to take some load off of maintainers and make it a little bit more automatic, keep things moving forward. The second tactical issue, I wanted to give a kind of a follow-up on the CAM roadmap. Now last year came to this event and I had just sort of shut down all development in CAM. I had said, I'm not merging another thing until we figure out how to do this, because I was facing the same thing in CAM that the maintainers are facing across the board in the projects, just so many pull requests coming in, and they're all over the place. And the time it takes to review things is longer than I've got to commit to a volunteer project. So I said, time out. We're gonna stop the development, and then we're gonna figure out how do we collectively do this. And that wasn't very popular with the development community initially. And in fact, people said, this, yeah, you're not going to work. And to some degree, it didn't. It didn't in the sense that we didn't get a traditional roadmap, but we did get some things that really did work. We got kind of a non-traditional roadmap. Again, we built a GitHub project that collected everything that the CAM was going on in the CAM, every issue and pull request that was tagged for CAM. And then we started sorting those things out. Another thing that we did is we added an ADR folder directly to the source tree. And the ADR is the architectural decision record. These are markdown files, human readable. They're right in the root of the CAM, or there's a roadmap folder in the root of the CAM module, and under that is the ADRs. And in the ADRs, we wrote down, you know, since it goes through a pull request, there's a draft and a review process and then merging it, but we're writing down the decisions that we made. How are we going to handle, what are we going to do with rotary surfacing, for instance? Or what are we going to do with nomenclature and terminology? So we added that. We also started taking all those issues that came into the tracker and we started breaking up into epics and looking at, we had a whole bunch of issues here. They're all related to post-processing. So we created a post-processing epic. And again, in the root of the source, there's a folder with the epics. And in there are markdown files that say, okay, we got an epic for post-processing. And that epic description says what's in scope and what's out of scope. What do we mean by we're going to spend some effort working on post-processing? And then we instituted these initially bi-weekly meetings, now weekly. Every Friday, the CAM developers meet up online, and we go through the GitHub project, but we also talk about, do we need a new epic? We're seeing a whole bunch of issues show up in this area, and, like, what do we want to do with it? That moved the decision-making about issue merging away from just me onto the group as a whole. And every time that's tried, it works wonders. It worked in the Monday merge meeting for the project as a whole, and it worked for CAM too. It's just one person can't know enough, can't evaluate thoroughly enough, so it helps to have more eyeballs on things. So those epics, they did a really interesting thing is they stopped us thinking about individual issues and started us thinking about groups of issues together. Like we pull all of the ones that were related to nomenclature and terminology. That is still ongoing work, but it ended up being resolved over the course of 5 or 6 or 8 pull requests. Same thing with the post-processing. Post-processing is many, many pull requests and still ongoing work, but it's also very correlated with the work we're doing for multi-axis machining, which needed a whole bunch of other pull requests. So we started thinking about these epics in terms of like groups of functionality and groups of related issues and then attacking them one by one. The ADRs, like I said, they make the decision easier. ADR 0000 is our ubiquitous language document. And this is a concept that came from the book Design-Driven, DDD, Domain-Driven Design. And it is, you define the language that you're using in terms of the domain. So we define what it means for a spring pass. We define what a tool or a tool bit is. It's all in there. That keeps the discussion amongst the humans on track. But the really powerful part is you point an AI agent at that ubiquitous language document, and if you're using an AI agent to review or to do assisted coding, it becomes much more effective. It's much less chatty and more focused on, and the results, at least the results I've seen, have been much better. So ADR 0000 has been like really, really important, and now it's to the point where if I'm using Claude or something for assisted coding, it's automatically keeping that ADR up to date and adding new terminology as it surfaces. The GitHub project was killer. It made a huge difference. The weekly meetings were also awesome. Right now we're getting routinely 5 to 7 people in there. We get people that drop in just to see what's happening. It keeps us focused on very actionable stuff. And then we do have, pull requests that get stalled just because, it's either too early or nobody's gotten time to review it yet. And having that meeting, at least we're talking about it. And it makes a delay in the pull request process a little more palatable. It isn't like everybody's ignoring me. You can go there, you can, we give a part of the meeting time to say, anybody have something they want to focus on right now? So, and then it also gives us a place to talk about the roadmap stuff. As a result, I don't know the total number of PRs that we've merged this cycle, but it's huge. 2026.3 is going to be it's going to be a really massive one for the CAM workbench. It added, in addition to the stuff that Chris showed, the new machine editor for actually defining a machine and its kinematics, and then the machine-based post-processing, which is a complete refactor of the post-processing pipeline. The new mill-facing operation, the actual, if you have a machine defined and it can do fourth or fifth axis, we can do like indexed fourth and fifth axis machine or tool paths. Let's see. So what didn't work? ADRs are still a slow burn process. There's only about 5 or 6 of them. ADR 000 was great, was fantastic. The other ADRs, they pop up, they get discussed, but I haven't seen them make a huge difference. They're useful, but it's more of a slow burn. We're learning to work with those things. Initially, we would do those meetings when we would review what was outstanding on an epic by epic basis. And that felt, at least to me, felt kind of artificial, kind of stiff. We felt like we were reviewing the same thing week after week after week. So we went back to, we've got a merge queue that's very much like what we do on the Monday morning meetings, and we kind of review everything that's outstanding. Generally sitting less than 50 open pull requests for CAM, and so we can get through that list in 90 minutes or so. We still tend to churn on things. We're often reviewing things that on a Friday, and we're like, well, we talked about it last week and nothing changed. So kind of still working to tighten that up a little bit. It did not add additional time to the week, surprisingly. But it did, at least from my perspective, I'll say it feels like we're more effective. And it is still hard to get through in less than 90 minutes. What it taught us, focus on the goals and more about epics than individual issues. All right, turning more to the strategic part. This is kind of taking what I learned from the CAM stuff and talk about what I think, like I said, when we come to meetings like this, you get a different kind of conversation. And my takeaway watching Chris's presentation this morning was all of these really big changes that came along were really driven by an individual. Trudeau worked on this, Paddle Stroke worked on this, Sliptonic worked on this. And the really big long-term goals for the project, the things that keep users and companies. When I was doing ONSL, I talked to a lot of different companies, and I would hear a lot of different things that they wanted from the application. Those aren't necessarily things that can be achieved by one person, certainly not in one pull request. There are more goals that are going to take more than one release cycle to achieve. They may take years or decades. But we don't have a mechanism for having those conversations. And I don't know that any open source project has. Doing a traditional roadmap and really guiding where the project is going to go over the next 5 years or 10 years is an unsolved problem in open source. But I feel like these real world meetings is the place where we should start talking about, well, what would that look like? How would we go about doing that? So overall, the project's never been healthier. Like it is, every metric that we track, we're getting better at releases. We're increasing the code quality. We're reviewing and merging PRs faster. We've got more developers on board. And at the same time, I'm seeing burnout. It feels less joyful, feels like a job. And we've lost some really important contributors to the project, either because of internal conflict or just burnout. And so, this is, for most people, an unpaid gig. We do it for fun. We do it for social connection. And we do it because we like tackling interesting problems. And, working on those bug fixes and those short-term features and polishing the workflow and the UI, it can feel like drudgery, but the thing that makes the drudgery worthwhile is if you kind of go into a long-term goal that looks more compelling. That's why I talk about the interesting problems. The interesting problems are the ones that, like, I would hear potential customers and users talk about. It's like, when's FreeCAD going to have like a web front end? All right, well, I'm sorry, that's not going to be a single pull request, and it's not going to be done over a single development cycle. And it's unlikely to be something one person can pull off. It's going to require coordination across the entire team. And that's if we even choose to do it. And we don't have a place to have those conversations or to do that work. So, old argument in the project, it always seems to be move faster versus move slower and be more stable. And there's really not an answer to this. It comes up every couple of years. People think we should be merging PRs faster and getting those issues in front of users. People think we should be moving slower and increasing code quality and stability. They're both right? For totally different reasons. And we're never going to really solve that. And the reason it doesn't get solved is because we don't have a place to put that risk. We don't have a place to work on those things that is risk tolerant, I guess. I mentioned a couple other things like, what would a browser-based FreeCAD look like? What would a Git native file format look like? These are just a few things that are meant to be like open-ended questions. Not saying we should do any of these things. It's more like trying to level set what would be, if we were going to have a conversation about like a research agenda, what would that include? What would be the things that we should spend some time on? I mentioned before that assembly is, a young workbench is getting a lot of work. Well, besides being able to handle 10,000 parts without completely blowing up, what does a really great assembly workbench look like, both from a user workflow perspective and a code stability perspective? So, open question here. If 50 experts walk through the door tomorrow, ready to work on FreeCAD, what would we put them to work on? You kind of have to ask that question because, regardless of what the project chooses to do or the policies that we set, we're seeing AI coding having an impact, and people are using it. They're becoming more effective. So we're seeing that the cost of developing around FreeCAD, add-ons to FreeCAD, and in the core, the cost of doing that is going down. All right, is the future of this project going to be tied to bug fixes and incremental improvements, or do we set some goals that are a little farther out and a little bigger? So there's a name for the thing that we're missing. It's a research agenda. And it's asking those questions that may take years to figure out. It's collaborative in nature. It's not putting the research onto one person. And it's really about permission to explore ideas that may never see the light of day, code that may never get merged at all. It's an experiment to find out whether or not we're going in the right direction. And the payoff of doing it is that it legitimizes work that is not wiggling your fingers on the keyboard and writing. It's legitimizing the work of research and planning and deciding what needs to be built that is going to take, that's the part of going out and talking to users. And it's reading the academic papers, and it's prototyping screens and getting it in front of users and seeing if we actually understood the goal correctly. We don't really put much emphasis on doing that part. We wait for a pull request to show up and then decide whether or not to merge it. A skunkworks is the place that you do that kind of stuff. And we don't have that. We have the development branch, but the development branch is really the next stable release. It isn't a place where developers can try out more radical ideas or bigger, longer-term goals, or get things in front of others to collaborate on earlier in a safe way that means this may never see the light of day, right? This may never get merged in this form. We don't have that right now. So it devolves into an individual's fork of FreeCAD and a branch that they're working on. And I would like to see us have something that is more, closer to like Debian's SID branch, a speculative, something that is, intentionally wild and hairy and broken most of the time, but fun. Something that is, whets the appetite and compels people to do more. So I don't have recommendations on this like I did for the more tactical things. This is more like recognizing that developing a longer term vision for an open source project's an unsolved problem. So let's have the conversation about how to do it. Let's try some things out and fail. Let's let's listen to what if people have ideas on how you do this and what you do with it next. The last strategic item kind of falls out of that as I don't step in the bear trap, and it's around the AI question. And there was some discussion here this morning about using AI code assistance and using it for code review and related topics. But I think it's really, really important to understand that while it's controversial, regardless of what we choose as policy for the code base or a policy for how the contributors to the project work on it, end users will want AI assistance in the application. They want the application to work well with their existing AI tools and to be more intuitive. And if we don't recognize that, and if we don't at least incorporate it into our thinking about it, then we're surrendering that territory to the commercial CAD alternatives, because they will build those tools, and those tools will be easier for end users to use. CAD is a hard application. It just is. CAD is, and it's always going to be a hard application. And so the users are going to want AI assistance to help them navigate that complexity of the models and complexity of the simulations. And so I think we need to consider those questions independent. There's the question of what we accept as far as code contributions and which tools we choose to use for our internal purpose. And then there's the question of which features that we're building and how does it fit into a landscape that is AI enabled. Let's see. I'm gonna skip that. And yeah, the real advantage that I see with the AI assisted stuff is it makes those experiments really so much cheaper than they were before. And that's, if we were talking about like a skunkworks or a research agenda, being able to do that and run those experiments in prototype up something very, very quick and get it in front of users and validate it. It also means that an individual developer doesn't have so much of their life invested in this thing that they're now fighting to get it in, even if it's sort of not on track. So I like the idea that these experiments get cheaper, and so we can do more of them. We obviously have to find a way to do it sustainably, but I think it's important to embrace the opportunity. And that's why I said, regardless of what we choose to do, users want it incorporated into CAD, or they want CAD-enabled features or AI-enabled features. So those are the 4 things I got, and then I'll open it up for Q&A if anybody wants to respond to any of those topics.
Yeah, you mentioned regarding the research agenda and like trying to figure out long-term vision and how to figure out what to work on. Is that kind of somewhat related to the existing working groups that exist? Like there's a design working group that's specifically for design, figure out things how that should work, or I'm not too familiar with that.
Okay, so the question was around how a research agenda would fit in with our existing working groups. We have the design working group and the CAD working group, code quality and so forth. And I think that, yes, that is, those groups would provide a natural place to have conversations around this. Right now, we mostly use those groups as an extension of the maintainers group to do kinds of specialized review that maintainers can't do directly. Like, you know, is this a good UI change? And so the design working group can really weigh in on, for the purposes of UI consistency and stability. So I think those groups have the expertise that would be a really important part of the conversation, but also at the same time, those groups are, you know, if we had a research agenda and a skunkworks, place where wild and woolly development is happening, what that would really let us do is make Maine become even more stable. Like, we could be more conservative around stability in the main branch, and those working groups would be weighing into that as well. Yeah.
Of course, the long-term findings, but some years ago, there were like multiple assembly workbenches, and then it was confusing which one to use, and now we have just assembly workbench. Are there any other third-party workbenches that are being looked at as like, maybe this is too universally used, that it just needs to be integrated into the main FreeCAD code bench for performance reasons, or otherwise? Are there any other workbenches like that that are being looked at?
We don't have a structured, so the question was about whether we are evaluating, you know, or even as part of a research agenda, looking at third-party workbenches as like, you know, pioneers towards functionality that would come back into the core. I think if I qualified the question right. Right, like Fastener's Workbench. And we don't have those discussions right now, don't take place like that. I personally love the fact that we've got a really vibrant add-on ecosystem, and you don't have to make the core application super heavy. It doesn't have to address the needs of every single kind of engineer or user out there. A user can customize it for what they need. The add-on, you know, the FPA is now paying somebody to work on the add-on ecosystem. Chris has done tremendous work around the add-on manager, and so it's becoming more reliable. It's becoming easier for us to, you know, recommend and encourage quality development there, and I hope that continues. The candidates that would be, you know, likely to pull into core is, you know, those places where there's extremely broad appeal, like the functionality is used by almost everybody, or where the code itself is best implemented in the core. But I mean, that's one area where it can be done, where we could do more research. Yeah.
Do you feel like OnCell was kind of the prototype for this skunkworks thing? Like, it was obviously a very intentional design-driven effort. Like, do you think it felt to me like that happened, that all that stuff happened at the exact right time that FreeCAD needed that directionality?
Right.
And I'm wondering if that model or a similar model, not that I'm asking you to go through that again, but like if something like that is what maybe needs to happen in order to have this intentionality back to the project.
Yeah. So restate the question. You're asking whether, you know, the changes that happen sort of in conjunction with ONSL, the topo naming push and the assembly push and the UI polish and so forth, all kind of happened at the same time that ONSL got going, and whether that is, you know, means ONSL might be a model for this sort of research agenda focus. I think kind of. You know, the thing about ONSL as a, you know, we're paying developers to work on things is we have a lot more freedom to, you know, be opinionated. It kind of freed us up to say, you know, we need stability, and that means topo naming, and the solution is out there, but it's unmergeable, and you know, to encourage the core project toponaming is a great example of one of those big things that, you know, I think that's the kind of thing we need to be biting off and going, you know what? Toponaming is really hard, and there's nobody here who can do it on their own. It's going to require a big effort, and it may require funding from FPA, and in the end it did. And so, you know, Ansel sort of gave us permission to be opinionated about what needed to happen. And then because it was up and running and we've got 5 or 6, 7 developers that are paid, it gets momentum. It allowed us to pay people to do blog posts and talk about things and raise the awareness of the conversation. And that was really important stuff. And like those blog posts really helped focus the discussion around what an assembly workbench should be. Not everybody was happy with the outcome, but I feel like we did the best we could in trying to synthesize all the important elements for that decision and then opening it up to the community about where we wanted to go with it. So I would love to see more effort like that. And maybe that's why, you know, it's such a thing with me is I feel, you know, I love open source. I really do. I've loved it forever. But open source tends to wander. And sometimes those goals are like, we all know where we need to go. But getting everybody on board and then carving that problem up into something we can tackle individually is really difficult. Yeah. All right. Thank you.